Hey, Topping Airlines Math Industry, and we're going to be continuing to use math to balance the formulas, and we're also going to continue what kind of reaction it is. In the last few videos, we have been looking at a synthesis reaction and a decomposition reaction. So we got those two covered. Let's find out which the next formula is, what kind of reaction it is. Here's the formula that we're going to be trying to understand what kind of reaction it is. Let's use math so we can balance the formula because it's not balanced. Then we'll be able to understand what kind of reaction it is. So we have zinc, hydrogen, and chlorine. Zinc, chlorine 2, and hydrogen 2. So, on this side before the arrow, there is one zinc atom, one hydrogen atom, and one chlorine atom. On the other side, we have one zinc atom, two chlorine atoms, and two hydrogen atoms. So, zinc is balanced because they both have the same number of atoms. On the other hand, hydrogen and chlorine are not. So what we're going to try and do is place a coefficient in front of the elements so we can balance them. So what we're going to try and do is have these two hydrogens turn into these. So we're going to have 1 multiplied by 2. So around the formula, we're going to try and put a 2 somewhere around there because 1 multiplied by 2 is 2. So, since there's a hydrogen and a chlorine right there, it'll help these two get to these right here. So, if we place a 2 right here, if we place a 2 right there, that is telling that these two elements now have 2 atoms. And voila! They're balanced because they have the same number of atoms. Since this formula is now balanced, let's find out what kind of formula it is or what kind of reaction it is. So notice that zinc is all alone in this part of the formula, but that arrow is telling you that this will become into this. But somehow hydrogen is not alone, but zinc is in a group with a friend, which is chlorine. So we call this a single replacement because a free element is going to be joined together with a friend while one of these two are going to be left out of the circle. Here's an example of a single replacement.
Squidward is my best friend in the world. Squidward is my best friend in the sea. Squidward
likes Patrick more than SpongeBob.
Patrick is a dirty, stinky, rotten seahorse. I can fix this.
So in that SpongeBob episode, SpongeBob was having an argument with Patrick. So SpongeBob decides to hang out with Squidward, making Patrick feel alone. So Patrick wanted to reunite with SpongeBob, but SpongeBob denies him with slamming the window. This is an example of a single replacement. Patrick feels lonely. Here is another formula that we're going to try to solve and balance. And we're also going to try and find out what kind of reaction it is. So let's get started. Na, or sodium, has 2. Sulfur has 1. Oxygen has 4. Strontium is going to have 1. That represents Sr. And chlorine is going to be 2. If we look on the other side, we have sodium is going to have 1. Sulfur is going to have 1. oxygen is going to have 4 strontium. That's a new element. That's going to be 1. And chlorine is going to be 1. So, what can we do to balance this? We can place a coefficient here. We can place one right here, here, or here. What can we do to get both sides to have the same number of atoms? Well, sodium over here and sodium over here are not balanced. So we're going to try and mess with this one. What we're going to try and do is add a 2, because 1 times 2, sodium now has 2. And there's a 2 on the other side, so they're now balanced. And we can also say that that 2 is also affecting chlorine. So now chlorine right here is going to be balanced. Chlorine has 2, chlorine has 2. Strontium 1, strontium 1. Oxygen both have 4, and sulfur both have 1. This formula is now balanced. And nice, we solved the formula and we balanced it. So what kind of reaction is it? Well, we have on this side sodium, sulfur, and oxygen mixed together. But on the other side, we have strontium, sulfur, and oxygen. So they're switched around. But sodium is no longer hanging out with oxygen and sulfur. It's now hanging out with chlorine. But before, strontium and chlorine were hanging together too. So this is called a double reaction. This is an example of a double reaction. So we have the white dye and the blue dye, and the white dye and the blue dye. When there's a double reaction happening, these two are now going to be together, and these two are going to be together. Just like the formula, they're pretty much switching up friends. Here's an example. That can be an example of a double reaction. In Super Mario Galaxy, Mario hangs out with this cute little space guy. And that purple space guy, he is hanging out with Rosalina. But in the end of the game, when you complete it and you defeat Bowser, that cute space guy that Mario hangs out with says goodbye and now goes back to Rosalina. But as Mario wants to go back home to planet Earth, that purple guy is actually gonna pilot the starship back to our home planet, which is Earth. Thank you for watching Taoping Airlines Math Industry. Like and subscribe. And there will be one more element that we're going to be reviewing in our next video.